Hey, this is Mr. Dittmer's Algebra 2 Intro to Graphing Trigonometric Functions video. Um, so I'm gonna try to get through some stuff pretty fast, and the idea is that you can pause me whenever you want. So um, if I'm going too fast, pause me, rewind to wherever it is. If you need to copy anything down, feel free and do that. I'm gonna be going through a lot of different web pages as we work. This one is called geogebra.org, and I basically used it's like that Desmos site that I'm always using, which I pulled that up as well, where you can type in an equation and get a graph. But GeoGebra also lets you draw like lines onto the graph, and that's what I was just doing. I'm also going to be going to the mathisfun.com website where I went up pull up the interactive unit circle. I think this is probably a good one to bookmark for yourself because it's really helpful to show how sine and cosine work related to the unit circle. Because basically, this whole week, what we're trying to learn about is these wavy graphs on the right side of the screen over here. And what we're more familiar with is this unit circle right here. But what we're going to learn this week is how the unit circle gives us these wavy graphs on the left. And we're going to focus on the red and the blue one, not so much the green one. The green one is tangent. We're really going to focus on sine and cosine. Um, so this is a really useful thing to have bookmarked. Also useful is the the coolmath.com unit circle webpage, which can be found in the pre-calculus section of coolmath.com. There's actually 6 different pages of that, and it's more about the unit circle, but that's good for us to review as we get into and then that'll help us then move toward these graphs here and what they are exactly. Um, I think there's that's about all the websites. Oh, and I'm gonna go this. You're not able to access this because you're not Mr. Hood, and he hasn't given you the password. And there's a good chance by the time you're listening to this, I'm not able to access it either because the password's about to expire. But these are the homework sheets. This is the software that generated the homework packets you guys have been using. We print these out and give them to you. Um, and this is going to be so a good place to start. This is going to be our objective for just this. I'm limited to 15 minutes on these screencasts and these videos. So in this first 15 minutes, you're going to identify periodic functions and find the period, midline, and amplitude of periodic functions. And the first thing that basically you're going to start realizing is that sine and cosine are periodic functions because they repeat themselves. And if I can go back here, that's the first thing that we're going to see illustrated on this packet is what a periodic function is. It's a function that repeats itself exactly, not just like sort of. Like here on the bottom, you have an example of something that sort of repeats itself. Well, that's not periodic because the repetition is not exact. Here, the repetition is exact. If you look at the function from 10 to 2, it goes down 2, then up 2, then up 2, then down 2. And then it does the exact same thing from 2 to -6. Down 2, then up 2, then up 2, then down 2. So there's a good visual. There's a definition. A periodic function is a function that repeats its values in intervals called periods. So that gives you not only the definition of a periodic function, but also the definition of what a period is. It's the interval over which the repetition happens, right? Like at the interval of 2, it's not repeating because this is different from this down here, and this down here is different from this over here. But over the interval of 2, 4, 6, 8, it's repeating. Every 8 are the same, so you would say this has a period of 8. And the other vocabulary so what other vocabulary did we have up here? We got period, we identified periodic functions, so we still have midline and amplitude to cover. So the midline of this particular periodic function is the x-axis. And you can sort of just see how it's the midline. It cuts it right in half from the top to the bottom. It's the midline. So except that we wouldn't call it the x-axis, we'd name it as an equation. So what equation is that cuts right through the center? Or what do we call the x-axis? As what is always 0 on the x-axis? Y. So y equals 0, we would say is the midline. Y equals 0 is the midline. And then the amplitude is, well, how high and how low does it go? How high does it go? 2. How low does it go? -2. Now, that means the total range of it is 4, but we say for the amplitude, it's 2. It's how far does it go from the midline. And we don't use the negative to say what the amplitude is. We always call the amplitude positive. It's like a distance. So the amplitude of this is 2. Let's see what we got for better definitions for these things. Here's another one. This one looks more like a sine-cosine function. Sine-cosine functions are not pointy and jagged like this. They're curvy like this. They make waves. It's called sine waves. So the midline here is y equals 4, and the amplitude is 2. It's still plus or minus 2 from the midline. So it's a little distracting that the midline isn't 0. So look, oh, I think the amplitude is 6, but no, it's just you got to subtract. What's the amplitude here? So I'll give you this packet. You'll be able to work on this on your own. But here's a definition of amplitude and midline. The amplitude is half the difference between the minimum and the maximum. So 6 minus, so one way, if you don't know what the midline is, but you just know the minimum and the maximum, well, you can subtract, you get 4, and then split this, of the overall 4, 2 is above, 2 is below, so you say the amplitude is 2. The midline is a horizontal axis that is used as the reference line about which the graph of a periodic function oscillates. Oscillates. Swings back and forth at a regular speed. A pendulum oscillates about its lowest point. So the midline is the horizontal axis past which, I can't keep track of my hands, the pendulum or the function, the periodic function oscillates back and forth past that midline. Okay, that's most of the notes that you need for this section. Hopefully you feel like you've got enough, but what I want to do now is just give you a preview for the next section of how this is what this is gonna have to do with sine and cosine, and why in the heck, why does the sine graph look like this? Because I think what you're most familiar with when I say sine or cosine graph, you're thinking of this. Like, well, Mr. Dittmer, didn't you teach us that on the unit circle, every point here is cos theta for x and sine theta for y. And and then we have to remember, well, what's theta here? Because really this is not the sine graph or the cosine graph at all. This is the graph of x squared plus y squared equals 1. And it just so happens that on that graph, that's also known as the unit circle, well, there's a certain angle matching up with, like, this is like 30 degrees, this is 45, and this is 60. Now, how is that? Why is that the case? Like, where am I getting the 30, the 45, and the 60? Well, some of you guys remember, but I'll sort of speak it outwardly. I'm doing it I made a ray right here on the x-axis, and then I made another ray right here, and the angle between those two rays is the thing I'm talking about. So, like, let's say, actually, I know it's not. I wonder if I can move it. Can I move this line? That's not what I meant to do. There we go. So that would be 60 degrees. I basically used that. I know that 30, 60, 90s have 0.5 as either the sine or the cosine. And so this has 0.5 as the x, so it's 0.5 as the cosine. So the sine must be root 3 over 2. Anyway, and I just memorized, oh yeah, 0.5. So this is 0.5, and then that goes with root 3 over 2. So whatever the angle happens to be from these two rays that we're talking about, like for this point here, it would be a different ray. So I can, GeoGebra, this is the reason I use GeoGebra, is it lets me make a ray. So like this point over here with 0.5 as the y, that's a different angle down here. So the angle is on this part of the graph, it's how far the angle from the rotation from the x-axis to whatever the ray is, and where it crosses the unit circle, that's where we get the points that happen to be the sine and the cosine of that angle. So that's what's going on the unit circle graph. It's not the graph of sine or cosine, it's the graph of x squared plus y squared equals 1, but it just so happens that if you, at every single point on there, this, like, the coordinate is always cosine theta, sine theta. That's just always the coordinate of that point on the unit circle. But it's not the graph of the unit circle. So what we have to, excuse me, that's on the graph of the unit circle, but it's not the graph of cosine and sine. So what we're talking about when we talk about the graph of cosine and sine is we're talking about an equation, a different function. We're talking about if we just say, like, so far we've been using cosine and sine to solve other equations, but we never looked at, like, well, what just happens if we look at cosine. What I mean to say is, when I told you, like, cosine is 36, well, we didn't have a lot of problems like that. Like, I didn't just give you that on a test, right? You would use cosine 36 to go, like, okay, so that's adjacent over hypotenuse, and then you'd solve it. But now it's like we're going back to just this process of, well, what is, 36 is my input, cosine 36 is, and you type it in your calculator or whatever, and you get an answer. So that's a function. Just like timesing something by 3 is a function, plugging something into the cosine function is a function. Just like, so you're going to get an input, 36, and some other output. And that's what this graph, the interactive cosine graph, which now, where'd it go? Did I accidentally hit? Oh, here it is. I accidentally keep going to aperiodical, whatever that is. So as I change my angle, my angle is my input. So my input's getting bigger and bigger, but on these graphs on the right of the screen, I'm just making the x-axis angles, and so you see the angles getting bigger and bigger as I go this way on the screen. But so right here at 45, the red and the blue cross, because as I get closer and closer to 90, the sine is getting smaller, the cosine is getting bigger, but then remember we learned about finding sine and cosine over here, and they have this behavior where now cosine is getting negative, sine is going back to 0, and then right here, cosine starts getting less negative, but it's still negative. Sine is now negative. They cross right at 225, and then now we're getting closer and closer to cosine's about to be positive again. Sine is bottoming out at -1, and now they get back, and then at every 360 degrees, what's going to happen at 370? They repeat, right? So it's going to do the same thing. So this is one period of the functions. And again, do your best to ignore the green. Every time we go around, so this graph repeats, 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 and you end up having a graph like this. Y equals sine x. And zoom out, and you see the repetition. Y equals cos x. Same thing, but just a little bit different. All right, more to come tomorrow.